Chapter 7, Section 4. We're going to learn about right triangles and using means. Now, this is a little different than the way I've taught it in the past. This is more of the Common Core, I guess, way to teach it. When you take a right triangle, and I'm talking about this right triangle right here, and you create an altitude. What's an altitude? Straight up, right? We're going to find out what the height of that is, the altitude of it. We go straight up from the floor, perpendicular to the floor. So if this is my floor and I go straight up with an altitude, I create this right angle here. When that happens, when you take a right triangle and you create an altitude off the hypotenuse of that right triangle, you find that this triangle here is similar to this triangle here. And similar means it has the same angles and their sides are proportional. All right? So we can figure some things out here. If we know that the angles are the same and we know that the sides are proportional, we can start using this to be able to figure out what our sides are based on if we're given, let's say, just two sides. So in this case here, let me go ahead and erase this here. They're given a problem here. I guess before I do that, this is the equation they give, okay? And this is called a geometric mean, and how to find the geometric mean. Remember, when our means and extremes, A over B equals C over D, our means are lower left and upper right. We're going to put x's in those. So we're going to write an equation like this. A over x equals x over B. That will be our equation to be able to figure this out. And if we're given the geometric means, the geometric mean, actually they're given the extremes, not the means, right, are going to be 8 and 12. We would place an 8 in the A over x equal to x over the 12. By all means, Alex, go ahead. So when we do our cross multiply and divide on this, we'd have x times x, which is x squared, equal to 8 times 12, which is 96. If we take the square root of both sides, x equals the square root of 96, and then we'd reduce it. This is what bothers me. There's so much more to it than just this little bit. I may end up teaching you guys that after this, but I'm gonna stick with this right now. I just think this really is limited what you can do with a right triangle within a right triangle. Okay? Because when you start working with extremes and means, there's a ton of things that you can figure out in this case, and they're really not having you do that. So my corollary here, the altitude of a hypotenuse of a right triangle divides the hypotenuse into two segments. Okay? So if I take an altitude and I create an altitude out of this right triangle from the 90 degrees to the hypotenuse, okay, I create this altitude. It divides this altitude, or divides this hypotenuse on the opposite side into two segments. I'm going to just call it X and Y right now. There's two different segments that it breaks it into. The length of the altitude is a geometric mean of the segments. In other words, between it, what happens here, it takes this right triangle and it creates two more right triangles. Okay? And this side right here is really what connects those two right triangles. So it creates a geometric mean of those two. If I had two right triangles that shared the same one side, I know, I wish it would. Why don't you go down? If I keep forcing it, think it will? No, I don't think so. All right. So what it's saying here now is the length AD, what I called X, is to CD this mean. Okay? The same as CD, this length, is to DB. Though it's a proportion. So, let me call this X, Y, and I'm going to call this M, just for a thing. X over M is the same as saying M over Y. There's a proportion there. That's what they're coming up with. They're using this length, this altitude, as the mean between these two segments. And we can use that to be able to figure out what the length of that is. Kind of goofy to understand? It is. It is. I actually like the way I do it better, but okay. How can I say this better? Bless you. No. Hey, Cade, stick with us. We're not talking about boxing and everything else. If we look at the altitude right here, this will be your mean. The length of that altitude will be your mean every time. So depending on, I don't care what is above here, this altitude I'm going to call M is always going to be lower left, upper right. The length of this right here will always be up on the top of the mean, and that's the shorter length, and the longer length is always going to be on the bottom. Is that, if I say it like that, kind of put it together? All right. I'll call that Y. Okay. So if you put this on top of whatever this length is, and you put this on the bottom of whatever length is, set it equal to each other, figure out the proportions. All right, corollary 2. The altitude of the hypotenuse of a right triangle divides the hypotenuse into two segments. We knew that. We take an altitude. We come from the right angle to the hypotenuse of this triangle, and we divide it into two segments. The length of the leg, original right triangle, is the geometric mean of the length of the hypotenuse and the segment of the hypotenuse adjacent leg. All right, they're using these proportions. Remember that we have two similar triangles. All right? We have two similar triangles. So if you take a look at the leg and the hypotenuse of the smaller, or actually of either one of them can be used. The leg and hypotenuse, it's the same as this is a leg of that triangle, right? This, if I was to break these out, This is 4 and 8. And then I look at this bigger triangle, which is like this. And here's my right angle, here's my right angle. This 8 would be the leg, and it would be 4 plus x. This whole length right here, 4 plus x would be my hypotenuse. If I was going to break those out into two triangles, right? Now, if we remember working with similar triangles, these are similar. My legs, 4 over 8, so I went from here to here, is equal to my hypotenuse, which in this case is going to be 8 over 4 plus x. That's back to when we were working with similar triangles. Remember doing that? Remember doing that? Okay, and now we can do the algebra on it. That's what they're showing right here. Break them out in two triangles, and I think you're going to be able to see how you can work with them. Let's jump down to write a similarity statement relating the three triangles in diagram. Okay. Mm-hmm. I'm going to do the practice on here. You guys will have the assignment. Hypotenuse of a right triangle is always opposite the right triangle. Kate, enough. Enough. See ya. Opposite the right angle. Could you close the door, please? Thanks. Is your hypotenuse. All right? So if I look at this right angle here for this triangle, this would be my hypotenuse for that right angle. Segments of hypotenuse. The altitude, we know what the altitude is. Segment of hypotenuse adjacent. Yeah, I'm not worried about that. I want you guys to be able to figure this stuff out. All right. We want to write similarity statements for this, and they're going to ask you to do that in the assignment. We have three triangles in this. Right here, we have three triangles there. First we have the large right triangle. We have a smaller right triangle here. And then we have the other right triangle. So we have three right triangles in there. All right? We have to write a similarity for them. So in this case here, my similarity is going to be A, B, C. This triangle right here is similar to notice my A started on the right triangle of this. So I'm going to have to start off, if I'm doing this triangle right here, I'm going to have to start on the right triangle there. It would be D, A, B. And then I look at where the right triangle starts on this one, would be similar to D, AC. Right? Those are your similarities. All right? That's what they're looking for on when you do the assignment. You have to be able to write your similarities this way. The bottom part, or the middle part, I should say, all they're doing here is you set up this equation. Remember, my means are on the bottom, extremes on the top. They're giving you actually your extremes here of 9 and 4, and you solve it. X times x is x squared equals 9 times 4, which is 36. X equals 6. That's what you'll end up doing in your homework as well. All right? And on the bottom is just complete the portion. What's the proportion? Look at where these are. Q and R. Q and R are the big part. They're looking at the big triangle here. And Y. What is Y attached to? Well, it can be attached to, we're looking at a leg. Yeah, what's that? Yeah, T would be your box, because you're looking at this triangle then right here. So T would be your box. Would be in the box. That's what you need to do on the assignment, guys. I don't like how this is taught, but I want to stick with what it's doing in the book. So do 1 through 9. Go ahead and do 1 through 9. Is there any questions on this? Do it, work on it. You got questions, ask, and we'll go over it, okay?